the RPS project. I'm Richard, and today I'm going to have a look at fans. That's computer fans. Now, have you ever sat there next to your computer and it's blasting out air, making a noise, and then you go around to a friend's house and their computer's nice and quiet and it's just gently working away, and then the fans sort of ramp up a little bit and then go quiet again, and you're thinking, why doesn't my computer do that? Well, that's probably the PWM, pulse width modulation. It's a control of the fans so that you can control the speed of them in relation to the temperature within the case or the CPU or whatever. And that's what I'm going to have a look at today. I'm going to have a look at some fans and how I can control them. So let's go and have a look on the bench and see what I can do with them. So here we have a selection of fans. Start with this one. This is a simple one. I think this is actually out of power supply, but I'm not totally sure because I'm this grid thing on it. But this has got 2 pins, just 2, which means it's just got voltage. It's just on, I suppose. I've then got this thing, a Kasa. It's got LEDs on this one, but this has got 3 pins on it, so there's a little bit more, I don't know, a bit more control on it, I suppose. I don't know until I turn it on, I suppose. But yeah, same size. That's a case fan, as far as I'm aware. This, I think, is from a power supply, but there's no reason why it can't have PWM, but this one just doesn't, just has 2 pins. That's got 3 pins connector, and then I've got these 2 things from Intel CPUs. Actually, these are from an i3 and an i5. Actually, the 600 milliamp one is from the i3, the higher wattage fan. Don't know why that's higher wattage than this one, which is from an i5. Stock coolers, but these both have 4-pin connectors with a well, these have got the same colours, but that's not too bad. So there you go. So I suppose what I'll do is start turning them on and have a look at what they do, and I'll start with the simplest and work my way up. So the Ace starts first. So here we have the 2-pin fan that I think is from a power supply. Now I'm going to be using this little bit of a, it looks just like spaghetti junction a little bit, but it's just going to help me to connect up to the connector on the back here, onto this these little connectors they have. And we're going to start with this 2-pin one. Now this 2-pin one will take 12 volts. Let's get that on there. Black to black, red to red, and that'll be it. 12 volts. Let's turn this on. Now the noise you actually hearing from the fan on my power supply, it's a bit noisy. It's an old unit, so it makes a lot of noise, just the way it is. So, and I have actually effectively got on here a diode, because I want to be able to make sure that if there's any back EMF on this thing, it doesn't suddenly spike it out, which it can do with things like fans, even though they tend to be quite good. But anyway, I digress. So there you go, a 2-pin fan. It's going to be either on or off, and that thing's on, and it's blowing out this way. On my fingers, let's do it a bit of I don't know, something that's going to flap about a bit. If I can't make it. See, there we go. That's sort of blowing out, and it's just on. It's on or off. And really, to control this type of thing, you'd either need to have something like a linear regulator to control the voltage. So it's either 12 volts, you turn that voltage down and slow it down, or you have something like a transistor. But a transistor isn't the best way to do it, really. You'd be turning the voltage on on and off all the time, so it affects the way the motor's working, which isn't brilliant. Yeah, so you know, 2-pin fan, very old style. This is from an old power supply. You'd get them as case fans, but that's about what they do. Don't put your finger in there. You can't say much better than that, can you? It's 12 volts, it's on, it blows air. There. Yeah, 12 volts on or off. So here we have the second fan. It's the Akasa, 12 volts. They're all DC 12 volts. Pretty much all of the fans inside your computer are going to be brushless DC 12 volt fans. This one has a 3-pin connector. The black, the red and a yellow, obviously ground, 12 volts, and a sense. I've heard it called a tachometric output sense line. Basically it just gives you a nice square wave output. Now from what I've read, you get 2 pulses from the fan for every rotation. So whatever the frequency is read as, then you just halve it, because obviously 2 pulses per second. So let's turn this one on. This one's got fancy LEDs on it. I suppose this is when LEDs and RGB stuff was sort of new. It's just static, by the way. And on the meter here I'll have the frequency. I can't really see it from this angle, but I will read it out, and on it goes. And we get 55 hertz. So that's divide that by 2. What, 27? No, there we go. It's flapping about. Now with this one, again, you've got this thing of control. How do you control a fan like this? You've got the issue of how do you turn down the voltage with a linear regulator? Do you use PWM through a transistor like you would maybe with the 2-pin one? You really don't have any control. You just know what the output is. It just tells you that you've got a certain frequency. But then with this one, the way this is connected up, the way this little box works, I can actually disconnect the ground wire, and the frequency goes up. It's now at 109 hertz. So we're talking about 50, well, you know, about 55 hertz. So we're doubling the speed almost of this fan if the 3rd pin isn't connected properly in the circuit. There we go, it brings it back down. So you've basically got a high and a low is what you get. You get a high and a low speed on these, which I suppose can be controlled somehow within the motherboard. It's a very crude control, but I suppose there is some control in there. Yeah, it works. Looks prettiest, I suppose. Got blue LEDs. Yeah, that's the 3-pin fan. Very simple, a little bit more control over it, but what more can I say? That's it. 3 pins. Let's move on. Okay, so now I've got the well, the CPU fan that I've got, the stock cooler for an Intel i3. It's got a 4-pin connector on it. Now the colours on this are black, yellow, green and blue, which is black ground, yellow 12 volts, green output or sense, blue control. So that's where we're going to read the output from it on this green wire, and we're going to put in a PWM control on the blue wire. So let's turn this on, and I'm using 25 kilohertz frequency on the input for this 4-pin, and 3.3 volts on that PWM control. It sounds logical. Computer power supplies and motherboards, they take 3.3, 5 and 12 volts, seem to be the standard voltages that you'd get with a computer motherboard. So I've gone with 3.3 with a duty cycle of 50%. So let's turn this on and see if it works, and it is on. So let's go to measure. So first of all, I better turn this on. So if I just go to measure at the moment and see what it's doing, at its current status we've got 32 Hertz. This thing is kicking out there. Now this is pushing the air down, so obviously I can't use my little bag to show the airflow, but it is blowing air down. And of course you can't hear it really because of my power supplies makes so much noise. But if I now turn on channel 1, that's now actually faster with a 50% duty cycle. If I go to measure, it's actually gone up. I've now got, well, it's about 57 Hertz, and of course with this thing again it gives supposedly 2 pulses for every rotation, so half 50, 58, so half that, you got about 28 Hertz. If I just turn that channel off again, turn it off, I'm going to be on there, that's it, then go back to measure, this string drops down to 32, so that's 16 rotations per second, which is quite slow really, but obviously I want to be able to control it. So if I go back to here, turn it on, and now I'm going to change the, oh, hang on a minute, it's on the wrong wave, it needs to be on pulse width. There we go, got that right. Someday I'll learn to use this equipment, you know, I really will. So now I'm going to change the duty cycle. I'm going to turn it up to 60. I can already hear that. And I go to measure. It's now showing 66 Hertz, which is 33. You're knocking everything else over. So back again. Yes, it's a bit goofy, this signal generator. 70. I'm now at 70% on the duty cycle, and I'm now looking at 75 Hertz, so 60, 70, is it 30, 40 is it? So 30, 30, 36, and so we're talking about 36, 37 revolutions per second. So let's just whack this up to something like 90. There we go. I can hear that now, it's really ramping up. So the PWM control is controlling the fan speed. I'm now at 46 revolutions per second. That's how fast this thing's spinning now. It's really going quite fast. I like that. So I've got complete control over this. Rack it up to 99. There we go. Let's go to measure. At 99 I've got, it says 100 Hertz, so we're talking about 50 Hertz, 50 cycles a second this thing's spinning at, so it's spinning quite fast now. I just wonder what its lowest is. Now when I turned it on, that's just, I don't want mode, measure, back to there, take the duty cycle back down, and at what point does it stop going down, I wonder. I'm at 25%. That's given me about that 15-16 Hertz. But if I turn that duty cycle down any more, say 15% on the duty cycle, I've still got about that 15-16 Hertz. So once I go below a certain speed on the PWM, on the duty cycle of it, this thing's got a minimum speed, so it'll always be on even if it goes below that, which seems to be sensible. I suppose if I turn channel 1, the output off, my control output off, then go back to measure, it's about 16. So that would be, if I turn this back on and turn the duty cycle up, about 24, 25, and then we'll have a look and see what the speed is. And that's about it. So it's without a signal running, without a control signal, this fan will always run as if there's a duty cycle of about 25%, presuming it's running at 25 kilohertz. I've no idea what frequency they put into those, but I've chosen 25 kilohertz because if there's any noise from the motor at 25 kilohertz, that's above the audio range. Whereas supposedly if you have it lower down, like at 10 kilohertz, any noise that this might create would be in the audio range. Don't ask me why. I don't know about the inside of these machines, these fans. That's to do with how they actually operate in there, but I have control of it. You know what, I'm going to get the scope out and have a proper look at this rather than just on the SIGGEN. So now I've connected up my scope, so might be able to see things a bit clearer now, rather than just trying to use my signal generator, which is great. It's doing what it should do, but this will really hopefully represent it. Again, we've got the stock i3 cooler with its 4 pins, and turn it on, and we get, and there's no control signal coming in. So without the control signal, this runs at its basic speed, which is actually about 24% on the duty cycle. This is 25 kilohertz I'm running at, but actually that doesn't matter because this is the output, isn't it? So I'm seeing my output. So if I turn on my signal input, you can see that didn't change. So that means that, yeah, without the control signal, the fan runs at about 24% on the duty cycle all the time as a base speed. So you always get some cooling. So it's never off, which is really quite good, isn't it? You know, you don't want it to suddenly just stop and not be on, because that wouldn't be good for it. It wouldn't be good for your CPU, that's for sure. If I turn up the duty cycle, we should see an increased frequency, and that is exactly what we get. Just keeps getting quicker and quicker. Just going to change that to DC coupled. Bit of drift in that signal. We just move that trigger level up and get it steady. There we go. And as you can see, actually on DC, because this is on 5 volts per division, the output is that right? 5, 6, about 7 volts. I've got about 7 volts output on that, and it sits up a little bit from ground. Just the frequency goes up. That's 99. So if I was to look at the measure, we said that's about 50 Hertz. Now I'm on 10 milliseconds per division, and we've got one full pulse, so we get 2 pulses per division for, yeah, 1 pulse per division. So 10 milliseconds, do the maths, yeah, seems about right, because it's halved. Yeah, that's about right. I'm not going to sit here and do the maths, I just want to see it working. But it looks like that's right. So turn that duty cycle back down all the way to that 24%. That seems to be its start point. And now I'm going to switch over to the control signal. Now, as you can see, I'm going to have to turn the frequency down, change that back over to channel 2 for its trigger, trigger down to 0, and as you can see, let's get that, well, a bit of a bounce there, but anyway, this is my PWM, this is my control. I'm running at 25 kilohertz out of the box, out the signal generator, and if I turn that duty cycle up, machine, the fan gets faster. I can hear it getting faster, and it goes up, and we're back on 99. You see that the fan's basically on all the time virtually now. So I've got great control. That's how my fans work. That's how they work inside your computer. This PWM signal on the control line, the green wire, is what makes it change. And so the 12 volts doesn't have to change at all. You've got a permanent 12 volts coming in, and then you get an output, so the computer knows what its fan speed is doing, and you've got a PWM input that controls it. Seems to be pretty simple to me. So there you have it. Fans for your computer, or power supply, whatever it's kicking out. 2-pin. It's on or it's off. You don't get any choice in it. And then you've got your 3-pin. Ones with fancy LEDs on. They're much fancier than this today. This one has 3 pins, but it's still just on or off really. You've got sort of like a high and a low speed, but beyond that, it's about it really. But it's a sort of improvement, because you now know how fast it's spinning, but it's still no real control unless you use a linear regulator or something to change the voltage. But then that's not ideal, because if you change the voltage too much, then the fan will stop turning. It takes quite a bit to get them going again. And then you've got this sort of thing. This is a CPU one, but I mean the idea is the same for a case fan. 4-pin. 4-pin connector allows you to have basically 12 volts supplied to the fan at all times, but then you have a control voltage, but that's a PWM, and you set the frequency to whatever frequency you want, and it stays there, and you just change the duty cycle, and it speeds up and slows down the fan. And of course you've got still got the output, the sense one, that gives you an output so you can see how fast it's running. So that computer, your motherboard, is going, yeah, I know what it's doing, I know how fast it's going, and usually with reference to a thermal sensor of some sort, it'll change the speed of the fan to accommodate that extra heat that it's trying to get rid of. There you go. Quite simple really. So I've got a project that I want to use these fans on, so being able to know how to control one of these fans is going to be very helpful. So I can connect it up, obviously not to a motherboard but to some other circuit, and I can control it now. Case fans, fantastic you could say, but there you go. Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.